So now, today we're going to look at the MIT Integration B Qualifying Exams 2010, Problem 1, which is the definite integral from x equals to 0 to x equals to pi over 2 of sine x, sine 2x, sine 3x, all multiplied together. Very interesting problem. We'll quickly look at this solution. Problem of the MIT 2010 Integration B qualifying exam, which is a definite integral from x equals to 0 to x equals to pi over 2 of sine x times sine 2x times sine 3x. So I personally would use the identity cosine to deal with this second part, sine 2x and sine 3x. So I would say cosine of A plus B equals to cosine A cosine B minus sine A sine B, right? And then cosine A minus B is equals to cosine A cosine B plus sine A sine B. And what that means is that when you add the right hand side and also if you add the left hand side, you have not adding, let's subtract. So you subtract the lower one, the upper one from the lower one. So you have 2 sine A sine B. I'm subtracting going upwards. And here we have cosine A minus B minus cosine A plus B. So if A happens to be 3x and B happens to be 2x, I would now say that the integral, definite integral from x equals to 0 to x equals to pi over 2 sine x sine 2x sine 3x equals to the same integral, and now we have sine x brackets 3x minus 2x is cosine x. 3x plus 2x is equal to 5x, so minus cosine 5x. Okay, this is coming dx. So this now becomes and since this is only 1, so this 2 divided on both sides, we have a half here and we have a half here. From this 2 coming this side, divide both sides by 2. So we have sin x cosine x minus sin x cosine 5x. Okay, so this now becomes sine x cosine x is half of sine 2x. So we have half two x over 2 and minus, we still have to um, battle with this a little bit. Okay, so we'll keep going. So now that we've seen our integral of sine x sine 2x and sine 3x being equal to a half sine 2x over 2 minus sine x cosine 5x dx. We have to deal with this part, and we can use the sign identity. Sine a plus b is equals to sine a cosine b plus sine b cosine a. Sine a minus b is equals to sine a cosine b minus sine b cosine a. So if we take the 5x to be a, it means that we could focus on this part, and what we'll do is we could subtract going downwards, right? And say that we have 2 sine b cosine a is equals to sine a plus b minus sine a minus b, right? So that if a is 5x, then that means we have 5x plus, then b is x is plus x, which is 6x, so sine 6x minus sine 5x minus x, which is 4x, and then we'll divide by 2 because we have that. So this integral here now becomes equals to a half sine 2x over 2 minus sine 6x minus sine 4x divided by 2, right? And we can pull the half out, so we have a quarter, and we have sine 2x minus sine 6x plus sine 4x dx. Okay. Let's keep going. Now we have our integral 0 to pi over 2 sine x sine 2x sine 3x being equal to a quarter 0 pi over 2 sine 2x minus sine 6x plus sine 4x dx. This now equals to a quarter cosine 2x integrated, and since this is negative 1 over 6 cosine 6x, negative and negative, this becomes a positive cosine 6x, and this becomes a quarter cosine 4x, 0 pi over 2. So limit wise, we have obviously a quarter out here. As x tends to pi over 2, this is cosine of 2 times pi over 2 is cosine pi is negative 1. Negative 1 times a half, we have times negative a half, that's positive a half. Cosine 6 times pi over 2 is cosine 3 pi. This is negative 1. This becomes negative a 6. And then minus a half cosine 4 times pi over 2. This becomes 2 pi. 2 pi cosine of 2 pi is 1. So we are left with a quarter there. Minus, on the lower side, we have cosine of 0 here. So cosine of 0 is 1, so negative 1 remains. Cosine of 0 here is positive 1, so we have positive 1 over 6. Cosine of 0 here is 1, so we are left with negative a quarter here. The quick things we can see is since this and this becomes positive, so this one's cancel. Now this is negative 1 over 6. This is negative 1 over 6 here. So we have 2 over 6, right? And then a half, negative, negative, this becomes positive. So a half plus a half is 1. 1 minus 2 over 6 is definitely 4 over 6. So this becomes a quarter times 4 over 6. And this 4 cancels. So we get 1 over 6 as the answer. Okay, so definitely we could have gone a little bit faster here, but because we just wanted to show the quick steps, especially trigonometric identities, with those I could have gone a little bit faster and just gotten them out of mind, but it was just showing you the process that I did follow. So until next time, bye bye, and I hope you did enjoy this solution. Ta-da.